So here we are at the end of our graphing or trig graphing section, and we have to graph tangent and cotangent functions. We're going to start with the tangent of x, and we're going to use the same tools that we used for secant and cosecant, meaning we're going to look at what happens around them rather than looking at them directly. They're sort of like looking at the sun. You can't really look at an inverse, or excuse me, at a tan, cotan, secant, or cosecant function directly. You have to look at it sideways so you don't burn your eyes out. So the tangent of x, we know, is the sine of x over the cosine of x. Easy peasy. Well, this has some really important information. One, if we can figure out where the cosine of x equals 0, then we know that the tangent of x is undefined. And if we can figure out where the sine of x equals 0, then we know that the tangent of x is going to equal 0. Luckily, we know both of those pieces of information. Let's start with the cosine of x equals 0. Then the tangent of x is undefined. So we're going to put in some asymptotes. We've been here before. Cosine of x equals 0 at pi over 2. Three pi over 2. And I'm going to go ahead and put 2 in on this side. Negative pi over 2 and negative 3 pi over 2. Basically, cosine x equals 0 at 2, nope, that's not true, at n multiples over 2. So pi over 2 times various integers, or multiples of pi over 2. So now we have a bunch of information, just like we did with the cosecant and secants. We know exactly where the tangent function has asymptotes. I'm going to change the spacing on this one because I don't like it. Okay, 3 pi over 2. Then, when we find sine of x equals 0, the information we're going to get from that is that tangent equals 0. Okay, well, sine of x equals 0 at, I didn't leave myself room to work here, at n pi intervals. So at 0, right? Sine of x equals 0 at 0. Sine of x equals 0 at pi, at minus pi, at 2 pi, at 3 pi, at minus 2 pi, at minus 3 pi, at intervals of pi. So what we know is that on two sides, the function is going to cross an asymptote, or approach an asymptote, and it's either going to touch and turn around at the x-axis, or it's going to cross over the x-axis. So we need some information or some way to determine what happens in between the two asymptotes. Well, luckily, we have a really great tool. All students take calculus. Now, this tells us the action or the behavior of this function, right? In the first quadrant, from 0 to pi over 2, tangent is positive. So if tangent is positive between 0 and pi over 2, the only shape it could possibly have is this shape. On that interval, because it's positive at that interval, that's the only shape it could possibly take. Then on the next interval, from pi over 2 to pi, tangent is negative. So let's mark this. They're all positive. Only the sine functions and the inverse and the cosecant function are positive. In the third quadrant, tan and cotan are positive. And in the fourth quadrant, tangent would be negative because only cosine and secant are positive. So, and when we move into the second quadrant, we know that tangent is negative. So it's going to look like this. We're going to have negative values that come up and touch at the x-axis. And then in the third quadrant, they're positive again. So it's going to do the same thing as in the first quadrant. And then in the fourth quadrant, you would have another series of this. And the same thing happens when I work backward, working backward from 2 pi to 3 pi over 2, tangent is negative, and so on. And so that is what the tangent curve looks like. One last thing to say about tangent functions is notice that they repeat. So they're definitely periodic. They're not sinusoidal because they're broken, but they definitely repeat. And the period for the tangent function is not 2 pi units, but it's pi. The period from negative pi over 2 to pi over 2 is pi, or the period from pi over 2 to 3 pi over 2 is also pi. So we can say that the period for a tangent function is equal to pi. So let's graph one of these. We want to know, or graph, y equals the tangent of 2x plus pi over 2. First thing we need to do is factor out a 2 to find out what b is. Well, we know what b is, but to find out the phase shift after we have made the adjustment. So I pull a 2 out front, and I'm left with x plus pi over 4. Pi over 2 divided by 2 is pi over 4. So now I can calculate the period. The period is the standard period divided by whatever b is, absolute b, but b is already 2. And so I know the period of this graph is going to be pi over 2, meaning the space between each asymptote is going to be pi over 2 units. But I'm going to use the point at 0, 0 and do a point translation first. I know that I have a 0, 0 on my graph, and if I use translations on it to see where it ends up, I know that I'm going to go backward pi over 4 units or subtract pi over 4 from the x-ordinate. So I'll have a point at negative pi over 4, and there's no translation on the y-axis, so I'm still on 0. And I think I have enough information now to graph. So let's sketch it quick. Well, maybe I should put it down here to make sure I have enough room, or at least over here. Okay, so I have this point, which is going to go backward to negative pi over 4. The curve is going to stay in this configuration because my amplitude is positive. Otherwise, it would shift over the x-axis and be opposite over the x-axis, but it is not. I have a positive a, and so I know that the curve is going to go like this. I just need to know where the asymptotes are. But that's pretty easy, really. If pi over 2, if the period is pi over 2, that means, and I know that this point falls right in the middle of the two asymptotes, from 0, or from the point out is going to be pi over 4, or half of the distance, and the point out to the left is going to be the other half of the distance. So I can say that I have an asymptote at x equals 0. I have another asymptote at x equals negative pi over 2, right? That's the whole distance of the period. I have another asymptote at x equals negative pi over 2 plus pi over 2 is pi. Then I'd have another one at pi plus pi over 2, or 3 pi over 2. I could go in the forward direction if I wanted and say I have an asymptote at x equals pi over 2, and I could just go on forever. I won't. And then I can label my point. So I know that the shape is going to stay the same, but I have to label this point. If my asymptotes are between 0 and pi over 2, half that distance, because trig functions are very symmetrical, is pi over 4, and that's on the negative side. If I were asked to graph more than one period of it, then I would want to do a positive pi over 4, or I could have chosen this point, or this period, and just do the math. Negative pi over 4 plus pi over 2 is 3 pi over 4. And that would be on the negative side. So I could do that on and on and on. Okay, so let's use the same bit of information we used before, the same type of information to figure out where the cotangent of x lives. Well, first, we know that the cotan of x is the inverse of tan of x, so it's cosine this time, over sine. And if we figure out where cosine equals 0, then we'll be able to say where the cotangent function equals 0. And if we find where the sine of x, then we'll be able to say where the cotan of x is undefined. Well, we already know that sine of x equals 0 at n pi. So that means I can say with confidence that I'm going to have an asymptote at 0 pi, which is 0, at 1 times pi, which is pi, so I can put in the label, at 2 times pi, which is 2 pi, and I could go on and on. Same thing in the other direction, at negative 1 times pi, which is negative pi. So those are my asymptotes. And then using the numerator, cosine of 0, or cosine of x equals 0 at n times pi over 2. So now I can put those in. 0 times pi over 2 equals, hey, that's not true. Let's see what happened. Oh, I see. I used poor notation here. What I was trying to say was that cosine x equals 0 at multiples of pi over 2 plus n pi. So what I said that was incorrect, the wrong thing I said, was at multiples of pi over 2, meaning that on the unit circle, cosine would be equal to 0 at 0. It would be equal to 0 at 1 pi over 2, 2 pi over 2, and at 3 pi over 2. But it's not true, right? This part isn't true. I only wanted the pi over 2 and the 3 pi over 2. So it has to be written instead as pi over 2 plus n times pi. So pi over 2 plus pi takes me to 3 pi over 2, plus pi takes me to 5 pi over 2, 4, 5 pi over 2, and on and on. So I used a notation error. This is actually written as pi over 2 plus n pi, which is what I did here. I'm sure you caught it and thought, oh, I can't wait to get to class and tell Marla what she's done wrong. But I caught it first. Yay. Phew. So now that we're back on track, we can put in our points. So pi over 2 plus 0 times pi means that I have a 0 at pi over 2. Pi over 2 plus 1 times pi means that I have a 0 at 3 pi over 2. Pi over 2 plus negative 1 times pi is pi over 2 minus pi, so negative pi over 2. And now all I have to do is sketch where the graph actually lives. And again, I'm going to use all students take calculus and evaluate each interval. So on the first interval, 0 to 90 degrees, cotangent is positive. So it could only take that shape. On the second interval, cotan is negative, so the only shape that fits an asymptote and an x right there is this shape. The next interval, again, tan and cotan are positive, and just like with the tan function, this shape repeats over and over and over. All right, one more quick example and we are out of here. Let's graph y equals negative cotangent 3x. Okay, so again, we're looking, let's evaluate the period. I didn't talk about that. So let's look at the period for a cotangent function. The period for a cotangent function is the same as the period for a tangent function, from 0 to pi, and then from pi to 2 pi. So the period for a cotan function is pi as well. So in our example, we want to rewrite y equals minus cotan. We don't actually have to do this part, but just to kind of keep it clear what I'm doing. If I factor the 3 out away from the x, I discover that I have no phase shift and I have no vertical slide up and down the y-axis. I do have a flip because a is negative, and I do have a b value of 3. So first let's figure out the period for this function. P equals pi divided by absolute b, which is 3. So I know that the period for this graph, this cotangent function, is going to be pi over 3, meaning my asymptotes will happen every pi over 3 units. This time I think that the easier way to graph is to deal with the asymptotes first. Since the points aren't going anywhere, let's put the asymptotes in. So I know that with no translations, I'm still going to have an asymptote at x equals 0. And I'm going to have an asymptote every pi over 3 units. So I go forward pi over 3, and then 2 pi over 3. And I could go backward to minus pi over 3. And all I have left now is to put in the points. Now the whole graph squishes up, which means I'm going to have points halfway between 0 and pi over 3 rather than halfway between 0 and pi. So halfway is pi over 6. And then if I go forward to halfway between pi over 3 and 2 pi over 3, that's really the same thing as pi over 6 plus the period, because they happen periodically. Pi over 3, so that would be a 2 times 6, 3 pi over 6. That would give us a pi over 2. Yep. And then minus pi over 6. And then the only other thing to look at now, I've already dealt with the period change, and now I just have to reverse the direction. So instead of going this way, our new graph is going to carve out or sketch out this way. Done.